Hello and welcome to this Scientific Principles video with Electraining. In this video we're going to consider the subject of Ohm's law. Ohm's law is all about the relationship between certain quantities within an electrical circuit. Now these quantities or these things are current, voltage and resistance. And we have to thank for this a scientist called George Ohm, who about 200 years ago discovered through experimentation that there was a direct connection between these three things within an electrical circuit. The current and the voltage and the resistance were all very much interdependent and affected one another. I'm going to talk about those three quantities now and just define each one of them. So the first one is current. And current can be described as the uniform flow of electrons through a conductor or round a circuit. So it's as the electrons move and they carry electrical charge, that's what electric current is. It's the flow of that electrical charge around the circuit. The unit of electric current is the ampere, and we use the letter A, a capital A, as an abbreviation for ampere, and it's named after a French scientist called André-Marie Ampère. And you will find that many of the terms we use in electrical science, many of the units, they're named after scientists who either discovered the principle or carried out experiments on them in the early days. And so when we look at formulae, or when we're writing a formula that includes current in it, we use the symbol I. So it gets a little bit more confusing now. So the unit is ampere, but the symbol in a formula is I. And I want you to think of current as flow. That's a good word to associate with current as we learn about these different electrical principles and these different quantities. Current is the flow of electricity. So think flow. The second quantity is voltage. Now voltage can be referred to using a number of different terms or different words. One of those is electromotive force, or EMF for short. So the EMF, or the voltage, provides a difference in potential. Now here we have another key word, all relates to the same concept, potential. So it provides a difference in potential between two open terminals of an electrical circuit. Now when the circuit's closed, this potential, or this potential difference, causes the electrons to flow around the circuit in a uniform direction, and that's the flow of current. So you see, we don't get the flow of current unless we have, well, two things really. We have to have a complete circuit, but we have to have a force that's applied to it, and the force is the electromotive force, or the voltage. The unit of EMF, or the unit of voltage, is the volt, and we have another scientist, this time an Italian scientist, Alessandro Volta, to thank for that term. It's named after him, the volt. And when we write the term voltage into a formula, we use the symbol for voltage, we use the capital V. Now EMF, or voltage, I want you to think in terms of force or pressure. That's the key understanding of what voltage is. It's a force or a pressure that is applied to the circuits. The third quantity is resistance. Resistance is essentially the opposition to the flow of current. Every circuit will contain a degree of resistance to the flow of current, and this opposition is something that has to be overcome by the voltage. There has to be sufficient voltage applied, sufficient pressure applied to a circuit to overcome the resistance that's there in order for the current to flow. Now the unit of resistance is the ohm, and you'll see a little symbol there, and it's the Greek letter omega, and we use that symbol for ohm as an abbreviation for ohm. The name itself, ohm, comes from that German scientist I mentioned, George Ohm, and the omega symbol is used simply because we run out of letters in the English alphabet, and so for some quantities we abbreviate using Greek letters. Now in a formula, the resistance symbol is R. So we don't write ohm in the formula, we write the letter R, capital R, to represent resistance. Now in terms of resistance, the best alternative words that you think of what resistance is doing, it's opposition. It's opposing the flow of current. It's resisting the flow of current. So there we have the three quantities in an electrical circuit about which Ohm's law gives us some very important information. We haven't yet actually defined exactly what Ohm's law is, but what we have said is that it relates to these three quantities: current, and I want you to think of current as the flow of electricity, it's the flow of electrical charge. We have EMF or voltage, and I want you to think of the voltage as the force or the pressure that's applied. It's the pressure behind that flow of current to cause it to happen. And the other word is resistance. So the resistance in a circuit is the opposition to the flow of current. And I've got a little cartoon drawing there that helps us really just to visualize these three concepts in relation to each other. So you'll see there we've got basically this represents the conductor, and it's being squeezed by the resistance. So there's a little cartoon character called ohm, and the resistance is reducing the flow of current. There we have the current trying to get through this opposition to the current flow, and so that's measured in amps. And there we've got the voltage, a little character called volt, who's pushing the current through. So the voltage is pushing the current through and trying to get through against the resistance. So hopefully that gives you a sort of general concept of the three interrelated ideas within an electrical circuit of current, of voltage, and of resistance. And in the next video, we'll now be looking at how Ohm's law defines that relationship specifically and looking at some maths that's involved.